Cool, guys. Now let's move on to next part, which is types of data types. So one thing is clear. We talked about different languages, compiled and interpret languages. We know that compiled languages are strictly typed languages and interpret languages are loosely typed languages. Now let's talk about what are the different data types. What are the categories of data types? Okay. So broadly, we classify into two categories. One is called primitive or predefined. Predefined something which is available in the language itself. You don't create it. And second is user defined, means you create that language. So we have two different type of data types. Primitive means if it is available with the language itself, for example, integer, character, you did not create the data type. They were already present in the definition of the language. You are just using it. User defined can be, I am creating a class, I'm creating an interface. I am creating that class. I am creating that interface. So that is user defined. Okay. This part clear to all? Enum. Enum is also a constant, but enum, if you give the definition, you can call this because you define what exactly goes in the enum. That's why. Okay. All right. Now, inside the primitive also, we have different categories. We have different types of data types. So let's divide into the categories, then we'll go to the types. The first category is a number. Second category is a character. Third category is a Boolean. Fourth category is a decimal or decimals. Number has four different types. It can be a byte. It can be a short. It can be an integer. It can be a long. User defined use primitive under the hood. Yes, they can use primitive. They can use non-primitive, whatever works. An interface can refer to another interface. An interface can be a combination of several primitive data types. Okay, cool. Then character. Character, we have just one subcategory. We call it as char. Boolean, we just have again one subcategory, which we call as a Boolean. And decimal, we have two subcategories. We call it as float and double. Okay. So defining the total primitive or predefined data types that we have four categories: number, character, Boolean, decimals. Inside these categories, we have different types. So in number, it can be four different types. It can be byte, it can be short, it can be integer, it can be long. For character, it is just one character. For Boolean, it's just one, which is Boolean. For decimals, it can be float and double. So 4 plus 1 plus 1 plus 2, that gives a total of 8 different data types. This part clear to all? This part crystal clear to all? Okay. Now, I'm going to talk about two important things here. The first important thing is there are certain numbers that you should know. And second part is the range of these data types. That is something very important for, which we'll talk about later. Okay. I see a lot of people getting confused between the range of integer or the range of long. If not getting confused, they have to memorize it. How many of you remember the range of integers? If anybody can mention in the chat. That's a wrong answer. That's the range of a short, by the way. That again a wrong answer. That's the answer you're giving is for short. I'm asking the range of integer. 65K is a wrong answer. Okay. When I say range, if you try to give anything else after that, it will give you a wrong answer. Okay. It will not work. So 2 to the power 32. Okay. Anybody else? 32,000 is incorrect. Cool. That's the reason I was coming to that. See, I'm not saying you should memorize it, but you should definitely know about it. In this session, I'm going to tell you the formula. I'll talk about everything. We'll start from the basic mathematics. We'll go to permutation combination. We'll understand how the formula comes. Okay. So we'll talk about the reason why the range is between certain values. I could have simply write down the ranges also. I could have asked to memorize it, but that's not the way I like to teach or I would like to make people understand. We'll go with step by step. We'll understand how did that range come from. And then I'll give you a formula with every data type you can calculate that range. Okay. So that will make it easier for you and you will never forget this again. All right. Cool. Starting with the first part. The first part is there's certain numbers in terms of memory that you should know about. When you say 1 bit, what does that mean? 1 bit means Bit is the smallest unit, by the way. Bit is the smallest unit of memory, not the byte. Byte is different, bit is different. One bit means either you're going to store 1 or you're going to store 0. True means 1, false means 0. That is the smallest unit of the memory. Okay. Then you have nibble. Nibble is 4 bits. Okay. Then you have byte. Byte is 8 bits. Then you have kilobyte. Kilobyte is 2 raised to the power 10, which is 1024 bytes. Understand one thing, guys. When we say kilo, mega, peta, anything, we are referring in the order of 10 to raised to the power 10, which is 1024. It is not 1000, it is 1024. Just to be clear, 2 raised to the power 10. Then we have 1 MB, which is 2 raised to the power 10 KB or 1024 KB. Then we have 1 GB, which is 1024 MB. Then we have 1 terabyte, petabyte, zettabyte, so on and so forth. You can keep on doing that. This part crystal clear to all first. This part clear to all first. Okay. Now we'll talk about the formula or the range of the data types, which will go to the next when we go to numbers. I'm going to first start with the simplest one, which is called character. Okay. So inside character, we have just one category, which we call as char. Let's talk about char. Character means you can store anything between A to Z, capital A to capital Z, 0 to 9. Any symbol, which can be in terms of star, in terms of and etc. etc. So you can store small a to z, you can store capital A to Z, you can store 0 to 9 or any symbols that you want to store. Okay. Let's start with the code. The code is character C equal to A. And of course, this is something that you should know. When we say single quotes, we are referring to a character. And when we say double quotes, we are referring to a string. Okay. Now, in terms of ASCII characters, we know that 1 byte is equal to 8 bits. So 8 bits gives me 2 raised to the power 8 size, which is 256. So I can store up to 255 characters. Okay. When I say 255 characters, each and every symbol, each and every number is mapped to each of these 256 characters. That's what we call as ASCII characters. Okay. So if I talk about A, the ASCII code for A is 97. And if I talk about small z, that is 97 plus 25. Similarly, if I talk about capital A, that is 65. And if I talk about capital Z, that is 65 plus 25. That's it. Okay. Why? What can't we store in character data type? What you can't store in character data type is a number. For example, if you make C equal to 1, 2, 3, you cannot store that. You cannot store that. Okay. Or you cannot store string. So if you make C equal to A, B, C, D, E, you cannot store that. Okay. Character is just for one character. So either you can store a 1 digit or you can store A to Z, capital A to Z, or any symbol. Something which is within the range of ASCII character, 0 to 255 bytes. This part crystal clear to all. Come on, guys, be quick. The simplest data type that we have, starting with the character, this is what character is. Okay, now interesting question, and this is something I'll give a homework as well. Feel free to search wherever you want to search. Search Google, ask anybody, then let me know the answer tomorrow. One moment, I'm coming to the question, right? But I'll want the answer tomorrow. I will not want the answer right now. The question is, how much size does a character takes? How much size does a character takes? Yes, 256 because that's the binary represent. 2 raised to the power 8. So that's why 2 raised to the power 8 is 256. Come on, guys. Question is, how much size does a character takes? One byte, 2 byte, 1 byte, 2 byte. Anybody else who's yet to answer? Okay. Interesting part is all of you are correct. In other languages, it takes 1 byte. In Java, it takes 2 bytes. 1 byte means 8 bits. In Java, it is 16 bits. My question is, why Java has a partiality? Why does a character takes 2 bytes in Java, but in all other languages it takes 1 byte? As I said, I don't need the answer right now. You can read about it, you can give the answer, and then once you are satisfied with the answer, then you can tell me the answer. Guys, signed unsigned has nothing to do with character. When we talk about integers and other numbers, signed and signed makes sense. Signed and signed is just positive and negative, right? So plus c and minus c doesn't make any difference. Plus 10 minus 10 do. Okay, cool. You can read about it, you can get to know, and then we can discuss it tomorrow. I'm just giving this as homework. Let me know why is there 2 bytes in Java and why is there is 1 byte in other languages. Okay, let's move ahead. So the first type that we have is a character. We talked about what does character store. We talked about the SKY characters, how does the mapping work, so on and so forth. Okay. Second type, again, easy one, which is Boolean. Boolean, as the name says. So here I can write the code example also. The code example is you can take character A and you can give the value of 5, let's say. This is example. Okay. Moving to Boolean. Boolean, as the name says, it store either a true or a false part. Okay. So it's going to be either 1 or 0. It's going to occupy only 1 bit, not the byte, 1 bit. So code means you can take a Boolean, you can make it A and you can make it to true or you can make it to false. The first two data types clear to all. The first two data types clear to all, character and Boolean. I'll talk about string. I'll talk about string. String is more of a data structure rather than a data type. So we'll talk about when we move to string. String is nothing. String is just an array of characters. Just for understanding, technically string is a data structure. Okay. Yeah, it's a class also in Java. It's a different data type also, no doubt about it. But technically string is a data structure, which is an array of characters. Okay. Cool. Now, if this part is done, now we move to the next part, which is category of numbers. So in numbers, we have different type. We have a byte, we have a short, we have a integer, and then we have a long. We have these 4 different subcategories when we talk in terms of numbers. Okay, we'll talk about these subcategories and the ranges, but before I go there, let's talk about how do we calculate the ranges. Okay, just for your knowledge, byte stores 1 byte, that's what is called byte. Short takes 2 bytes, integer take 4 bytes, and long take 8 bytes. This is something that you should know, you must know. Okay, byte takes 1 byte in memory, short take 2 bytes in memory, integer take 4 bytes in memory, long take 8 bytes in memory. Okay, now we are going to talk about formula. How do we calculate range of these number types? Everybody clear with this? Okay, let's start with a formula to calculate range of data types. All right, let's start with the basics. So we are just going to use simple maths here, and that's how I'll calculate the answer. How much bits are there in 1 byte? How much bits are there in 1 byte? 8 bits. Okay. 1 bit is just 0 or 1. Okay. Now understand for a 1 bit memory diagram for 1 byte. 1 byte is there, means there are 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Every place which is a bit, you can either fill 0 or you can fill 1. Now let's talk about it. You are given 8 different chairs, let's say, or 8 different tables, whatever you want to visualize it. Each of these chair can be filled in 2 different ways. So if I talk about ways to fill any one place, there are 2. You can either fill by 0 or you can fill by 1. Can you guys tell me the total number of ways to fill complete 8 places. Come on, guys. Simple permutation combination question. If one place can be filled in 8 ways, sorry, one place can be filled in 2 ways, what are the total number of ways to fill the complete 8 places? All agree with that? Simple mathematics? Okay. The simplest way is the first way you can fill in 2, the second way you can fill in 2, the third way you can fill it 2, fourth you can fill it 2, so on, so on, so forth, till 8 number of times. So what does this number becomes? This number becomes 2 raised to the power 8, and that becomes 256 different ways. So there are 256 different ways to fill those complete 8 places. Okay. Now, interesting part comes here that gives me a spectrum of 256 values. Okay. Out of that 256 values, there is something called 1 bit, which is out of these 8 bits, 1 bit is reserved for parity. Parity or sign, whatever you want to call. Means what? Usually that bit is least significant bit, which is on the leftmost side. Significant bit. That is reserved for sign of parity. Means if we have +5, the code is 0101, binary code. And if you talk about -1, 0001. Okay, it will just flip on the least side. This is what we calculate in 2's complement. We don't calculate the negative numbers binary as we do it in the positive number binaries, dividing by 2 and calculating that. We don't do that here. We do that with 2's complement. But anyways, you don't need to go in that much depth. The point is, you are given a total spectrum of 256 values. Out of that 8 bits, 1 bit is reserved for the parity or for the sign. What does that mean? If I am dealing with unsigned values, unsigned value means only positive values. If I'm dealing with only positive values, I have the entire 256 available to me. So the range will go from 0 to 255. But if I'm dealing with signed values, means it contains both positive and negative values, then it will be split in half. So -128 to 127. This part crystal clear to all, yes or no? Come on guys, be quick in the chat. Everybody clear? Okay. So once you have reserved 1 bit, the left number of ways become 2 raised to the power 8 minus 1, which is 2 raised to the power 7 ways. Okay. So when we talk about the formula, what does the formula becomes? Number 1, whatever data type that is given, just calculate the number of bits. So you calculate number of bits from bytes, just multiply by it. That let's call that number as n, number of bits. Second, if 1 bit is reserved for sign, which is positive or negative values, whatever that is. Third, you would have a range which is -2 raised to the power n minus 1 to 2 raised to the power n minus 1. This is in the case of signed. And if it is unsigned, then you get a very straightforward answer. This will be 0 to 2 raised to the power n minus 1. That is in the case of unsigned. The formula clear to all? How did we get to the formula? This part clear to all? Yeah, I have written it this way. Can you explain signed and unsigned alone again? Okay, let's go back again. Let's understand this, then we'll come back to the answers of these numbers. Now it becomes very easy to understand, but let's go through this. First thing first, 1 byte contains 8 bits. Every bit can be filled in 2 different ways. So if I talk about 1 byte, remember, I'm just talking about 1 byte here. So 1 byte can give me 256 different ways to fulfill. This part clear to all? Okay, now let's move to part. There are two different types of data types, or two different types of numbers, not just data types, numbers. One can be unsigned, what can be signed. The only difference between unsigned and signed is signed can take both positive and negative values, unsigned cannot take any negative values. Okay, so out of the 8 bits that we have, if I'm going to keep something for my sign, I just reserve 1 bit. Okay, I just reserve 1 bit to tell me whether it's a positive number or negative number. How would you differentiate whether it's plus 20 or minus 20? So to understand the differentiation, we reserve 1 bit for that. That is in the case of signed numbers. So if I reserve 1 bit, now the range which will be reduced into the half, because now I'll have 2 raised to the power 7 and 2 raised to the power 7 minus 1. So if I divide 256 into half, where I'm including 0 also, so it will become minus 128 to 127. Because if we combine this value, both inclusive, this will give up to 256 answer. Agree? Minus 128 to 127 plus 0. So total will be 256. And if I don't have to reserve that 1 bit, then I have the entire range available for positive number. So 0 to 256, both inclusive, it will be also 256. This statement clear to all? This part clear to all? Okay. If this part is clear, now we talk about the formula. The formula is whatever data type that is given to you, convert that into number of bits first. Let's call this n, number of bits, not bytes. If you are talking about signed integer, then in that case, range will become minus 2 raised to the power n minus 1 to 2 raised to the power n minus 1, because 1 bit is reserved. If you're talking about unsigned integer, range will become 0 to 2 raised to the power n minus 1. This statement is still clear to all? Yes or no? Yeah. This part. Okay. All right. If this part is all, now let's move on to the answer. 0 to 2 raised to the power n minus 1 minus 1. You can put here also. Or you don't need that. 2 raised to the power 8 minus 1. This is good. Okay. Now let's start with an example. So in the case of byte, let's start with the byte. If I have a byte, 1 byte is equal to 8 bits. So what is the value of n here? The value of n here is 8. So if I talk about the range of bytes, I'm talking about signed bytes here. The range will become minus 2 raised to the power 7 to 2 raised to the power 7 minus 1. All agree with this? All agree? Okay. Let's take for integers. Now start with integer. Integer take 4 bytes. 4 byte means 32 bits. Now my n becomes 32. So range will become what? Minus 2 raised to the power 31 to 2 raised to the power 31 minus 1. This part clear to all? This was the exact answer that I asked the question, range of integers. Okay. Or you can also roughly say, if you have to remember, you can roughly keep like minus 2 billion to plus 2 billion on a roughly basis. Okay. Next, let's move on to long also. If I talk about long, long take 8 bytes, 8 byte become 64 bits. 64 will become n here, minus 2 raised to the power 63 to 2 raised to the power 63 minus 1. That is roughly around 40 trillion. Okay. And then let's do for one more, which is for short. Short takes 2 bytes. 2 byte becomes 16 bits. So n becomes equal to 16. So minus 2 raised to the power 15 to 2 raised to the power 15 minus 1. Some of you are giving the answer 32,000 something. That is the answer for short, not the range for integer. Okay. Cool. So let's write down the ranges. Byte. We just talk about the range of byte. What's the range of byte? It's going to be minus 2 raised to the power 7. Copy this. This is 15 and this will be 15. This is 31. This is 31. This is 63 and this is also 63. Everybody crystal clear with this? I hope now you don't have to forget or you don't have to memorize it. It's good that if you know it, if you don't know it, you don't need to memorize it, because now you know the mathematics behind it. Okay. And since you know the reasoning behind it, I don't think you will ever forget this. Okay, you can calculate it as many times. All right, this was the 4 types of in terms of numbers. We have 2 more types when it comes to in terms of decimals. We have a float and we have a double. Okay, these are the last 2 data types that we have, float and double. So in decimal, we have 2 different data types, float and double. There's a difference between the two. When you say float, let's take a number 223.251234. Copy this, paste it here. Float is going to store up to 4 decimals. So 223.2512. This is 4 digits decimal. But double is going to store until 8 digits decimal. So 223.25123400. So this is 8 digits decimal precision. This is 4 digits decimal precision. And that's the only difference between these two. Float takes 4 bytes, which is 4 digits decimal precision. And double take 8 bytes, which is 8 digits decimal precision. Everybody clear with this? Everybody clear with this? Okay. To your question, why are we using -1 here? Let me explain here. See, the reason you're using -1 here because 0 is also included. So when you say 0 to 255, 0 is also included. So when you include 0, total values become 256. That is why we are subtracting 1 here. Okay. All right, guys. I think I've talked in detail about the data types in terms of one moment. How to difference between signed and unsigned, then if range -2 plus. I didn't get the question. Can you explain me again? How to differentiate between signed and unsigned, then if always range -2 plus. So, okay, you're asking in which case I have to use signed, which case I have to use unsigned. Is that your question? Okay. Yeah, I'm coming to that. You're talking about the use cases. I'm coming to that. See, every kind of question you solve, you will be given the constant that you're dealing with. If you're dealing with negative numbers or positive numbers, if the constant says only positive numbers, then you have to go for the signed values. Okay. Sorry, unsigned values. And if the question says you have negative and positive, then you have to go for unsigned values. We'll talk about it. Anyways, coming back, we have talked in detail about types of data types. I've explained the number, character, Boolean, and decimal. In detail, we have talked about byte, short, integer, long, character, Boolean, float, and double. Everybody crystal clear with this? Give me clear in the chat. All cool? Okay. Now we are going to start with something important, which is the use case. We know that there are different type of ranges of different data type. We know that there is signed. One moment. One question, reserved bit. See, the reserved bit is reserved to say the parity. So whatever is the sign of parity, that is what we have the 1 bit reserved for it. So imagine like out of the 8 bits, 1 bit is keeping the check whether it's going to be positive or negative value. The rest of the 7 bits are available to you. Okay. Is the range same for float as that of a 4 byte as we are dealing with decimal values? No. The reason decimal values are stored are different from how the integer values are stored. Okay. So the range is not same. So when we say -2 raised to the power 2 to raised to the power, it is not valid in the case of decimals. It's in the size. What do you mean by in the size? Is reserved bit in the size? Yes, yes, it is in the size, right? So if 1 bit is reserved, that's why we have the range from -2 raised to the power n minus 1. This n minus 1 is because 1 bit is reserved. That's why. Okay. All right. Now let's move on to the next part. We talked about the different data types in terms of numbers and as well as other data types also. We talked about their ranges. We talked about signed and unsigned. We talked about the reserve bit. Now let's try to understand what is the use case of that. Why should I know these values and where I can use that information to make a decision? So case number 1. In every question that you deal with, you would have something called constant. So if you have like, you probably would see something like this, 0 less than equal to n less than equal to 5 into 10 is the power 4, something like that. Okay. What does that constant means? That constant I hope everybody has seen those constant, by the way. Whenever you solve any question, irrespective of any platform, lead code, hacker rank, hacker earth, there would be something called constant. That is what will decide you or will tell you against which range of values your test cases will be there. Okay. So you wrote a certain piece of code, but what exactly are the range of test cases against which your code will be testified? That is what this constant is. Okay. Cool. Now, what piece of information, based upon this piece of information, what important decision I can make? Let's talk about that. So if I know that the n is going to be between 0 to 50,000, okay, what's the range of byte? Let's start with that. The range of byte is minus 128 to 127. We are just talking about signed as of now. So can you store 50,000 in something which has a range of 127? Can you store 10 liter of water in a bucket which has a capacity of 2 liters? You cannot. So you cannot store 50,000 in something which has a capacity of 127. So it is not going to be a byte. Is it going to be a short? Is it going to be a short? Come on, guys, be quick. Short has a range of minus 32568 to 32567. So short is also not satisfied. If you take unsigned short, yes, unsigned short can fill within this category. But if I talk about signed short, this is not filling in the category. What about integer? Integer we know minus 2 billion to plus 2 billion. So can it store? Integer n can store? Yes, integer n can easily store this part. So use case number one is whenever you're given the constant, they are given for a particular reason. So when you're given the constant, you need to know, 768 232 767, whatever that 2 raised to the power 15 is. Okay. Now, the reason these constants are given, these constants are there to mention you what is the range of values you're going to dealing with. Based upon that range of values, you can choose an appropriate data type. This part crystal clear to all? Yes or no? This part crystal clear? Okay. Yeah, if they are dealing with only positive values, you can go ahead with unsigned. So if instead of integer, you want to take it as unsigned short, that is correct. That will work. Okay. All right. What else? Let's talk about second use case. Case number two. Now the constants are relatively small. So I will take minus 52 plus 50. Now you guys tell me, n is between 0 to 50k, then n can be byte also. No, n cannot be byte, right? Byte will not fit within the range of this. Even if you take like unsigned byte, that will be 0 to 255. It can be unsigned short, it can be integer, it can be long. Okay. All right. Moving to case number two, which is the constants of minus 52 plus 50. Now you guys tell me which is the best answer or what should be the best data type to choose n here. Should it be byte? Should it be short? Should it be integer? Should it be long? Okay. Let's discuss the answer. First, when you're dealing with small constant like 50, I'll just take this guys here. Can a byte satisfy the answer? Yes. Can a short satisfy the answer? Yes. Can integer satisfy the answer? Yes. Can a long satisfy the answer? Yes. All of them can satisfy the answer. But 2 raised to the power 63 to 2 raised to the power 63 minus 1. Something important to notice here. This will also satisfy, this will also satisfy, this will also satisfy, this will also satisfy. I cannot make all of them. I cannot make byte and short and integer and long. I need to choose one. Which one will you choose and why? See, you can still get the answer in 1 byte. Why do you want to store in 2 byte, 4 byte, or 8 bytes? As a good programmer, you should be very efficient of your time and memory. Very, very efficient of your time and memory. So this is going to be the best solution here. Why? I can still deal with the ranges that I'm dealing with by taking only 1 byte in consumption. That's all. Now moving to the last part, I would just give you some trick. So when you deal with next similar type of question, you know exactly what to go for. I'll keep on giving such tricks while during the course. So if I talk with the constraint, let's say given a constraint like this, 0 less than equal to n less than equal to something like this. So what is the best choice here? Long. As a general rule of thumb, this is an important trick that you should keep and remember. Majority of the question, 90% of the question that you'll be dealing with online assessment or interviews, they are going to deal with the range of less than equal to 10 to the power 9. Okay. For that, use an integer. If it is less than equal to 10 to the power 15, use a long. If it is less than equal to 10 to the power 21, use a long long. Long long is in C++, it is not in Java, by the way. If it is less than equal to 10 to the power 30, then in Java we have something called big integer. And if it goes anything greater than 10 to the power 30, then we don't have a large number that can deal with that. Either we can create a custom type or this is what you're actually going to use. This is what we call a string. Okay. In Python, since it's not a data type, it's a data type in the sense it is not, there's any limit for that. So you can use whatever you want. There's no defined limit in Python and JavaScript. This is for compiled languages.